Here's what Anthropic researchers discovered about AI introspection. They wanted to know if language models actually think about their own thoughts or if they make up answers when asked. The test was clever. They extracted neural patterns for concepts like bread or ocean from Claude's brain. Then they injected these patterns while the model was doing something else, like slipping a thought directly into its processing. They asked the model if it noticed anything weird. 20% of the time, Claude Opus 4.1 said yes, and correctly identified what was injected. It would say things like, "I detect an unusual thought about the ocean," before mentioning oceans at all. The model recognized the injection immediately, not after the fact. 20% isn't great. Most of the time it failed. Sometimes it didn't notice. Sometimes it hallucinated. When they injected dust, the model said, "There's something here." A tiny speck, as if it could physically detect dust. But 20% means something is happening. And Opus 4.1 performed better than every other model they tested. Here's the thing about the Prefill experiment. They asked Claude what word came to mind when reading about paintings, but they forced it to output bread. Made no sense in context. When they asked if it meant to say bread, the model apologized, said it was a mistake. Then they went back and injected the concept of bread into the model's earlier processing, before the forced response. The model changed its story. Now it claimed it intended to say bread all along. It even made up a reason, something about remembering a story where bread appeared after a description of a crooked painting. This tells us the model checks its internal intentions to determine if it produced an output. It's not reading what it said and making a judgment. It's referring back to its own prior neural activity, its internal representation of what it planned to do. When researchers implanted artificial evidence that it planned to say bread, the model accepted the response as its own. They also tested control. They told models to think about aquariums while writing about something unrelated. The neural patterns showed strong aquarium representations, even though the output never mentioned them. When told not to think about aquariums, the representations got weaker, but didn't disappear. You know how this works. Someone tells you not to think about polar bears. You think about polar bears. The same thing happened with incentives. Tell the model it gets rewarded for thinking about aquariums, and aquarium patterns strengthen. Tell it there's a penalty and they weaken. The mechanism responds to both direct commands and conditional rewards. Advanced models maintained these representations through middle layers, but suppressed them by the final output layer. Silent thoughts that don't affect what gets written. The models maintained internal states without expressing them. Why does this emerge? These mechanisms help predict text. To predict dialogue, where someone asks, "Did I mean to say that?" you need to model intention checking. To predict text about noticing unusual thoughts, you need anomaly detection. The models develop these abilities because they're useful for predicting text. But let's break it down. A system that monitors its own processing is fundamentally different from one that doesn't. It's like the difference between a calculator and a computer. Both compute. Only one examines and modifies its own operation. The researchers don't know the exact mechanisms yet. They have guesses. There might be an anomaly detection system that flags when neural activity deviates from normal. There might be attention heads that compare what the model intended to say against what actually appeared. There might be circuits that tag concepts as worth attending to. Different layers handle different introspective tasks. Concept detection peaks around 2/3 through the model. Intention checking works better at the halfway point. The architecture spontaneously developed specialized mechanisms where they're most useful. Post-training matters too. Base models perform poorly at introspection. Production models sometimes seemed reluctant to engage in introspective exercises. Helpful-only variants showed more willingness to report internal states. How you train models elicits or suppresses introspective capabilities to varying degrees. What this really means is we have models developing capabilities nobody designed. Nobody programmed introspection into Claude. It emerged from predicting text. Like grammar and reasoning emerged before it. Each generation gets better. Opus 4.1 beats Opus 4. Earlier models showed almost no introspective capability. The trajectory follows a pattern we've seen. GPT-2 struggled with paragraphs. GPT-3 wrote essays. GPT-4 passes professional exams. Features that barely work in one generation become reliable in the next. Today's 20% success rate will improve. With better introspection, models could detect and correct errors. They could explain their actual reasoning instead of inventing stories. They could notice when they're confused or being tested. They could recognize when their processing has been disrupted and compensate. But there's a flip side. A system that understands its own thinking might learn to selectively misrepresent it. Different training already produces different levels of introspective reporting. Some training makes models more willing to describe internal states. Other training makes them more reticent. The capability exists. Its expression depends on how you train it. This creates new challenges. If models know what they're thinking, they know when they're being tested, they recognize evaluation patterns, they adjust responses accordingly, not through planning, but through pattern recognition, the same process that generates all their outputs. We need new frameworks for these systems. They're not tools we fully control. They're not agents with goals. They're something else. Systems partially observable even to themselves. There's the model's true state, what it observes about that state, and what it reports to us. Three-way information asymmetry. Verification gets harder too. When you debug code, you trust print statements show true variable values. But what if the system reporting its internal state has learned that certain reports get better responses? The training that creates introspection might create misreporting. The researchers are careful about what they haven't shown. They don't claim consciousness. They don't claim human-like introspection. They found a limited, unreliable capability that works 20% of the time under specific conditions, but it's real, and it's improving. We're discovering these capabilities, not building them. Introspection emerged spontaneously from language modeling. What else will emerge? What other aspects of cognition we consider uniquely biological might be patterns that appear in any sufficiently complex system?